Welcome to the channel, guys. Well, today I'm going to show you how we built this. It's an old LG washing machine motor, and we're going to do some testing at the end of the video here and show you what kind of power it makes. Just spun up with a drill. That's all I have to power it. And I can spin it by hand and generate decent voltage, so pretty confident this thing's going to work just fine. So yeah, enough talking. Let's get to the build. I'll show you how we put this thing together, and hope you stick around. If you haven't already, like, subscribe, share, comment. You know the routine. I hope you find this video interesting. Let's get to it. So we got the stator. We got the rotor. I have a wheel bearing here for a 2013 Malibu. I've knocked the studs out of it already because I don't think I'm going to need them. But if I do, I can put them back in easy enough. We've got a section of 1-inch threaded rod. Now that length will depend on how you'd plan on driving this thing. If you're going to use a pulley, direct drive, you know, that would be a variable I can't really explain to you because I don't know how you're going to use this, if you're going to use it at all. But anyways, then we've got a Tractor Heim ball I bought at Tractor Supply. I also bought this threaded rod at Tractor Supply. I bought a 36-inch length of it and cut it off. This is a 7/8 washer bored out to fit the 1-inch because I wanted it to fit nice and tight. And I mean, I can't even hardly move it on there. It's definitely tight. So, because that's actually going to keep it centered in the hub here. Well, that's my plan anyway. 2 1-inch washers, 2 1-inch nuts, another 7/8 washer with 2 wraps of electrical tape to give it the proper spacing. Because it was, and then I bored this out to fit the 1-inch, just with a die grinder. I don't have a lathe, so I just took my time, tried to get it as precise as I could. And again, it's not perfect, but hopefully there's enough tolerance between the stator and the rotor. I went ahead and cut out the hub pattern on a piece of steel here with the plasma table. I started doing it with a hole saw. And yeah, like, I don't know, I've said it in other videos, I hate drilling holes, and that was going to be a dang all-day process. I programmed it in the table, burned it out, the hub fits nice and tight, so let's get to assembling. And then the bolts I had were actual hub bolts that go through a knuckle. So I had to put some shock sleeves on there to space it out. I'll get the right bolts later, but right now that'll work. All right, so we're going to start by installing the hub, which is just a matter of 3 bolts that go here, here, and here. Now it does have a magnetic pickup for the ABS, so I'm sure if you were crafty enough, you could put some sort of sensor on there to read the RPM. Now this is a tight fit, so which I wanted because I didn't want it flopping around, you know what I mean? I wanted everything to center itself as best as I could. And again, I don't have a lathe, so thankfully I have a plasma table because like I said, drilling that pattern out for that hub with a hole saw would have been a nightmare. I started and then realized again how much I hate drilling holes. I'm hoping you guys can see what I'm doing here. I'm just bolting the hub in, so nothing. There's 3 bolts and 3 shock sleeves so the bolts can tighten up without going through the hole and hitting the back of the hub, so that spins free, you know. Like I said, I'll get the right bolts later, but this is all just for testing. Now I've got to figure out how to get the stator mounted onto the plate. So I think what I'll do is wrap the stator, the stator with some electrical tape, a few layers, get it centered, and then figure out how to get the bolts in there to hold that nice and straight and at the right depth, because too deep it'll hit the bolts, and not deep enough it won't make any power. So give me 1 second and I'll show you how we're going to do that. All right, well, what I ended up doing was wrapping all the way around the stator with about either 4 or 5 wraps of electrical tape, and then slid the rotor on. This wasn't even mounted yet. That was how I got it centered to find out where it needed to be. And I made these bolts out of some manifold hardware I had laying around. These are actually like the newer Dodge exhaust manifold hardware that holds the manifold to the cylinder head. Anyways, and I had these and some nuts laying around, but I needed to space it out 1 inch from the back of this plate. So I bolted everything together, and then actually, I'm going to have to pick you up and bring you over here now. Tack welded these on, and then pulled everything back apart, and then welded the nut that fit the bolt into that. It's just tack welded here and here, and then these are tack welded on each side. And that spaced me out 1 inch exactly from the back of this plate. So that worked out good. So I didn't record that part of the process because I wasn't sure if it was actually going to work. So now we'll get the stator bolted on. And I also had to orient it so this would orientate. Anyways, had to make sure this wasn't going to hit the plate. So this is actually on a slight angle. And goes on just like that. I'll get these bolts started here. I'm sorry if you guys can't see what I'm doing. If it makes you feel any better, I can barely see what I'm doing. So it's just not a good place to film over here. And I need it in the vise because it just holds it, you know what I mean? So we'll get these in and then we'll get this tightened up. And then I'll bring you back when I get the axle, when I start installing that and the rotor. So let me get this all tightened up and I'll bring you right back. All right, so here's our axle shaft, I guess you'd say. Now what's nice about these hubs and why I chose this hub is it doesn't actually need to be torqued down to stay together like a normal wheel bearing would. This, on that particular part number, works. And again, 2013 Malibu, works front or rear, works at all 4 locations. So it does not need an axle going through it with a nut torqued down to hold this hub together. That's why I chose this particular hub. There are lots of them out there, but I wanted to find something, you know, cheap as possible. You can get these for around $40 to $50, possibly even cheaper online. I bought it at my local parts store, but I have an account, so I get a better deal. But I did find them online, you know, through like Detroit Axle or something. You could get 2 for like $80. So, but not that you need to, but it'd be nice to have a spare in case something went wrong. Anyway, so again, this is a 7/8 washer that I used my die grinder to make it big enough to just barely fit over this 1 inch shaft. And I mean, it's so tight I can hardly even move it, you know. But that's what I wanted. And then I'm using this category 1 Heim ball, which fits the 1 inch nice and tight. Well, it's not as tight as I'd like it, but it's tight enough to center this shaft, because right now, and that's the function of this washer as well, to center this side in this part, like it's a tight fit. You know what I mean? Once that's in there, it doesn't really move. And then this, because it's cylindrical, it fits just inside where the axle goes through. And actually, you can see a line on it. It centers itself because it's nice and cylindrical. So that was my thought process behind that and why I chose to do it this way. Again, trying to keep everything centered because the tolerances are very tight between the rotor and the stator. So I'm going to hit this with the impact real quick. Sorry, it's going to be loud. That's plenty tight. Couple ugga-duggas, you know. Anyways. Alright, and that seems to be spinning freely. So let me get the rotor and I'll show you what I had to do to that to make it center itself. Alright, so on the washing machine, this is the hub. Well, 1-inch threaded rod obviously isn't going to fit through that, so I had to take that off. It's just held on with 3 little screws, and I actually put them back in there just in case I want to use them for something. But again, I took a 7/8 washer, machined it out. Don't know if you can see how I just used my die grinder and did it all by hand because I know I'm beating a dead horse here, but I don't have a lathe. I really want one. If anyone has one laying around they want to send me, feel free. Anyways, so, and then I wrapped it twice with electrical tape because this washer was slightly smaller than this. And then, so it presses in there pretty tight. It's actually pretty hard to get in there. But once it's in there, it's nice and centered, as far as I can tell anyways. And I did make some marks. I don't think it matters, but I did anyways. Just so I know how it lined up with everything. Then we'll just shimmy this over the shaft here. Now, these magnets inside this rotor are pretty stout. So getting it on, and the washer's a tight fit, so everything combined, it's a little bit of a trick to get it on there. So anyways, then we'll take another nut and another washer and put that on the back side to hold the rotor. And I'll go ahead and give that a couple ugga-duggas. That should be plenty tight. That Snap-on electric impact's a nice unit. And as you can see, if you listen, nothing's rubbing. Now, it was pretty bent when I got it. I did have to straighten it out. That's what these blue marks are. I basically held a marker along the side, and wherever it touched, then I tried to bend it out. But if I keep my finger there, you can see how bent it is. I don't know what happened to this thing, but I don't know. It's spinning and not touching, so we're gonna. It could be a lot better, but it's good enough, man, for who it's for. So I did actually buy a 1-inch pulley, the smallest one I could find, to drive this thing with my little electric motor. Come to find out, the electric motor doesn't have enough guts to get her going. I mean, it would, but I burned up the reset switch on it and everything else because it's not a high torque motor. It's just a little tiny motor. I thought it was going to be plenty because of the way I can just spin it by hand so easy. I mean, and the factory wiring for the 3-phase, I'm just going to keep that. It's got a nice plug and seems to work fine. Now, I will be hooking the 3-phase for testing here. I'm going to hook it up right here. But when I do it, when I get it out set up, this will actually be inside, and I'll run my 3-phase from the generator, or the alternator. Let's not call it a generator. I'll run that all the way till we're touching. That puts the brakes on. Anyway, so I'll hook these up inside, and then this will go straight to my battery bank through a meter so I can monitor what's going on. All right, let's do some open voltage testing here. Trying to figure out where you're going to be able to see this thing. I'm just going to spin it by hand. You can see we're making pretty decent voltage just by hand. So now we'll spin it up with the impact here, nice and slow. That's barely spinning and we're making 60 volts DC. Let's spin it a little faster, up to 100 volts. A little bit faster, we're at about 125. See what we can do here. Oh. Yeah, that's the problem with trying to use an impact for this. Yeah. Oh, about 225, 250, 260. Definitely high enough voltage for charging a battery bank. And the goal with this was low RPM and good output, because Vaught's are notorious for being terrible. So, all right, let's get it over and do some actual testing, hook to a battery bank, and see what she'll do. All right, let's do some testing on this bad boy. See what kind of power she can make. I'm gonna try and got to start it with the drill, and then I'm hoping this motor will take over. We'll see. Give me 1 second here to get everything set up. All right, well, here it is all set up. You can see all 3 phases. I got the lights off so you can see the screen, but you can see all 3 phases go to that full bridge rectifier. And then it comes out positive, negative. I got 8 6-volt batteries hooked up for 48 volts. But they're so terrible that it's not even anywhere near 48 volts. But it'll get up there once we start spinning her up, I hope. And I'm going to set you right there. It's going to get loud. I got to use my air drill to get this thing rolling. So just because that little motor I have hooked to it, it's high RPM, no torque at all. So I don't even know. We'll see if it's going to spin up and see what kind of power it makes. And I'll just spin it by hand here real quick and show you. I mean, it's pretty low speed. I was just spinning it by hand. So let me see what we can do here. Bear with the noise here for a second. I won't run it long because it's going to be loud. This air drill's loud. So. All right. I don't know what we made there, but I know it's generating power. I'm just not sure how much. I'll have to look back at the video here. But that was a good test run, and that's very low speed. That drill only does 700 RPM, so should be, and there was no way it was doing 700 RPM. But you can see how quick them batteries are going back down. They're junk. I was only getting like, I don't even know. Some of them were 12 volts hooked in series, a pair of them, and then some of them were only like 1.5. I mean, they're total junk. That's why we took them out of the golf cart to begin with. So, well, I guess that's it for testing it. I don't want to keep testing it with the drill and everything. It's just hard on everything. So I'll, next video, we'll start building I'm going to do a vertical access wind turbine for this thing. I was going to originally do it with the diesel that we did in the couple videos back there. So I can run it on my homemade fuel. But the problem with that is I can find a pulley, but a clutch for that stupid thing, because it's got a 20 millimeter shaft, is like $450 or something. I'm not, unless I can come up with a different way to get a clutch on there, because I need it to be able to start, not underload. Then I want like an electric PTO clutch for like a tractor, you know what I mean? I might have to actually put it on the shaft. I don't know, but it's not going to go on the motor either way. That's just not going to work. So next video, we'll get building the Vought, a vertical access wind turbine, for those that don't know what that is. I'm going to make it out of what I got laying around. So it's kind of what we do.